interested in it because they want to control whatever happens. They're going to control network traffic. In terms of the users, they're going to complain if the ISPs decide to fraud their traffic. And it's the whole cat and mouse game that we will move into, where every step the ISP takes to control traffic, BitTorrent takes another step to evade that detection. So what I'm saying is that, yeah, they're both interested in it because they put an end to that war, basically, that's going on today. And in fact, there have been some proposals, I think Yale and Verizon actually working together on a project called P2P, which is in the related work section. And their paper hasn't been released yet. But it's under submission, and there's this P2P working group, which these people at Yale are working with Verizon to try, in effect, to do what we're proposing. From what I read about their submission, it's a little different, and it involves a lot more state and communication with an application device. So there is, yeah, the stakeholders are pretty interested in what's going on.
I remember from some time ago, and unfortunately I haven't tried keeping up with it since, but there was a lot of discussion about moving to trackerless BitTorrent. I wonder what's the state of that, and does it interact well or poorly with what you're proposing?
Yes, you're right. The new version of BitTorrent does have that option, the trackerless torrent. The way trackerless torrents work, it's not that it's trackerless, it's just that the tracker is distributed in the form of a dynamic hash table. Now, what I'm saying is that the functional tracker still remains the same. So in effect, what we're proposing does still work. Because remember, we are not really proposing a direct change to the tracker protocol per se. It's not like, and that's another thing about using network device, we're not expecting explicit communication between the trackers and the network device. The network device does its job and informs them, so it's not like, but yes, we've considered that, and yeah, most of the new clients do have that option. But you'll also note that today, with all the parity and all these huge trackers going on, that it's still a dominant, the centralized tracker is still a dominant system used to be.
So you showed on your graph download time versus number of swarms thing. As you increase the number of swarms, download time actually went down. That seems a little bit counterintuitive because you would expect that by having larger swarms, you have more peers to choose from, so you'll be able to choose better peers. Do you have any intuition as to why it happens the way it does?
So you're saying that as the swarm size increases, the download time? Yeah, we actually are investigating that, and it has a lot to do with the selection algorithm. First of all, the unit at which BitTorrent clients share in terms of pieces, block sizes. So what happens to a certain extent, the goal is to select pairs that have pieces that I don't have. There's this block diversity issue where the client implements this. First, when I connect to a swarm, I have a bit vector of all the pairs that I'm connected to, and it tells me who has what block. I try to identify the pairs that are the rarest among my localized set. And we feel that that rarest first algorithm is the reason why the download times effectively increase. Now, what you have to understand too is that you see an increase in download time, but that is minimal in terms of the pair set, because we had 8 pairs and we had 15 pairs, and you see a small increase. Now, if that was a typical client, now that's the whole thing about BitTorrent, is that yes, download times will increase. We expect it to increase because of the fact that the distribution, you assume a distribution of pieces among pairs. And remember, it's not like, it's variable, and it's this random nature of it that causes this, and I think it has something to do with the pair selection algorithm. And we are actually investigating that, and we have some data to analyze on to why is it that download times increase. And that's a big question that we're trying to figure out too. And you have to also understand something too, that our experiment was done not with a typical, because typically in your DSL and your cable modems, you have an asymmetric connection. You have a low upload capacity and a high download capacity. Our experiment did not model that. Our experiment simply modeled what BitTorrent people call a university node. There were symmetric links in our experiment, and that's not typical on the internet. So that might be another factor why you see that difference, but we are investigating that.
So, I just had a couple questions. How do you detect?
Well, we don't have anything going. Nobody else is coming. Otherwise, I would have cut this off. But I mean, should we let our
everybody
actually go?
How do you detect local traffic like IPM? How do you detect expensive links? And secondly, why do I care that I'm using the expensive link? I'm always paying $30 a month, and if the ISP cares so much, and if they throttle the expensive link, wouldn't the existing algorithm automatically detect
care because when your download rate starts to decrease, you wonder why. And the reason that's not necessarily true that the local peers, you're saying that the local ISPs have a higher download rate. That's not universally true. It might be the case that there's network congestion to consider and all of that. But what I'm saying to you here, because if ISPs start to detect your traffic, they can throttle your download rate. You get a slower download rate. That's why you here, and then I think it's just trying to resolve the tension because, as we said, it's two opposing views. One trying to maximize profit margins, another one trying to maximize download time, and it's just this push. So
I think I think Helen's right. I think maybe we should call it. Any other questions you can ask here offline? All right. Thanks very much.